Hello everyone, I am Susmita of Isabella Thoburn College, Lucknow, and my topic for today's video is graph theory. So what is a graph? A graph G is a mathematical structure consisting of two sets, capital V and small e, where capital V is a non-empty set of vertices and small e is a non-empty set of edges. So in this examples, we can see, in the first example, we can see that we are having vertices V1 and V2 and it is joined by an edge E1. Now some basic terminologies. So first is a trivial graph. What is a trivial graph? A graph that consists of only one vertex and no edge. So in the example you can see that there is only one vertex. Here in this you can see there is only one vertex and there is no edge joining the vertex. Now second is the null graph, a graph that consists of n number of vertices and no edges. So in the example you can see that we are having these four vertices and there is no edge joining these vertices. Now third is the directed graph, a graph that consists of the direction of edges, then this is called a directed graph. So in the example given you can see that there are several vertices and edges and these are having a specific direction. Here you can see that this V1 and this V2 edge is joined by a even edge. V1 and V2 vertices are joined by even edge and it has a specific direction and this is shown by the arrow here. Now fourth is an undirected graph. So a graph which is not directed, then it is called an undirected graph. In the previous directed graph you can see that these are directed by the arrows in the specific direction, but in the undirected graph the graph is not directed in any direction. Now fifth is the self loop in a graph. So if edge having the same vertex as both its end vertices is called self loop. Here you can see that it's an edge, there is only one vertex and this edge is starting and ending on this vertex only. It's starting from here and ending it on the same edge. So this is called the self loop in a graph. Here in this example also you can see that that's a directed graph, it's a normal directed graph, but here at the vertex V3 you can see that there is a vertex and E3 edge is starting from V3 vertex and it's ending it on the same vertex. Now sixth is a proper edge. So an edge which is not self loop is called a proper edge. It is clear by the definition that the edge which is not having self loop, this is called as a proper edge. Now seventh is the multi-edge graph, a collection of two or more edges having identically end points. It means that, for example, we are having V1 vertex and V2 vertex. Now it is joined by the edge E1, by edge E2 and by edge E3. So there are three edges but having the same identical V1 and V2 vertex. So this is known as the multi-edge graph. Now 8 is a simple graph. So a graph that does not contain any self loop and multi-edge. So here in the example you can clearly see that it is neither a directed graph nor it having a self loop and not it having a multi-edge. As I have told earlier that self loop it's shown by that it is having a vertex and edges starting from that vertex only and ending it on the same vertex. And for multi-edge you can see that we are having two vertex and it is joined by multiple edges. So in the simple graph there is no self loop and no multi-edge, so it is called a simple graph. Now ninth is the multi-graph. So a graph that does not contain any self loop but contain multi-edge, so this is called a multi-graph. Here in this example you can see that it is a simple graph only, that it is having a v1 vertex, v2 vertex and v3 vertex, and here it is having v4 vertex, but there is no self loop but it is containing multi-edge. Here you can see that the here you can see that the vertex v3, here you can see that the vertex v3 and vertex v4 is joined by an edge e3 edge e4 and edge e5. So there are two edges joining the same vertex v3 and v4, so it is called a multi-graph. Now 10th is a pseudograph. So a graph which contains both self loop and multi-edge, it's known as a pseudograph. So in the example you can see that the graph in this graph the vertex v2, this vertex is having a self loop in it, that the edge is starting from that vertex only and ending it on the same vertex, and it is also having a multi-edge. Here you can see that the vertex, that this vertex and this vertex, it's connected by two edges, this one and this one. So this is known as a pseudograph which is having both self loop and multi-edge. Now 11th is the incidence and adjacency of the graph. So let EK be an edge joining two vertices VI and VJ, then EK is said to be incident of VI and VJ. So the two vertices are said to be adjacent if there exists an edge joining these vertices. So in the example you can see that E1 is incident of V1 and V2. You can see here that this is the V1 edge and this is the V2 edge. So it is joined by the E1 edge. So E1 is called the incident of V1 and V2, and V1 and V2 are adjacent but V3 and V4 are not adjacent. Now 12th is the degree of vertex. So the degree of vertex V in a graph G written as d of V is equal to the number of edges which are incident on V with self loop counted twice. So in the example you can see that this is V1 edge, it is joined by V2 edge through this edge and to V3 edge through this edge. So the degree of the vertex is equal to the number of edges which are incident on V. So here this edge and this edge is incident on V1, so it will be having degree 2. Now the vertex V2. For vertex V2 we can see that it is joined by this edge and this self loop. So in the definition you have seen that degree of the vertex is equal to the number of edges which are incident on V and with self loop which is counted twice. So this V2 edge is joined by this edge and this self loop. So this is one edge, this is two, this edge and this self loop, it is the first edge, this is the number 2 and the self loop is counted twice, so it will be 2 more. So on adding these two, degree of the vertex V2 will come as 4. Now for edge V3, we can see it is joined by this and this edge only, so it will be having degree 2. Now V4 edge, it is joined by this edge and this edge, so it will be having degree 3. Now for V5 edge, it is joined by this edge, so it will be having degree 2. For V6, so this is the V6 vertex, it is joined by this and this edge, so it will also be having degree 2. Now V7, this is the V7 edge and it is joined by only this is the V7 and it is joined by only this edge, so it will be having degree 1. Now for V8, this is the V8 edge and it is not joined by any edge, so it will be having degree 0. So this was all about degree of vertex. Now 13th is the isolated vertex and pendant vertex. So a vertex having 0 degree is called isolated vertex and a vertex having degree 1 is called pendant vertex. So in the previous example, you can see that this V7 edge, this was the V7 edge and it was joined by only one edge. This is the V7 vertex and it is joined by a single edge. So it is called a pendant vertex, and this vertex V8, it is not joined by any edge, so it is called the null vertex or the isolated vertex. Now 14th is the finite and infinite graph. So a graph with a finite number of vertices as well as edge is called a finite graph, otherwise it is an infinite graph. So in the example you can see that this graph is having a finite number of vertices and edges, but in this graph you can see that there is the infinite number of edges and vertices. It is going on and on. It is not having a finite number. So this is known as the finite and infinite graph. So this was all about the graph theory and some basic terminologies. So thank you so much for watching, and I hope you all liked the video.